Okay, we're going to talk about vectors.
Oh, crap.
Oh, I know.
Say vectors.
Okay. I don't even label it.
Where did you go? You didn't really tell me.
6th grade.
Almost did Cocoa Beach.
Okay, does anybody know what a vector is?
Yes, did, but I forget.
Starts with point
Yes.
and keeps going in one direction.
Okay, so it looks like a ray, right? Do you know what it represents though?
No.
Okay. So vectors kind of look like this, like rays.
Oh, I knew that.
So like what a vector is. Okay. So definition of a vector. It's something, it goes in some direction, so it represents quantities that involve magnitude, so both magnitude and direction. You know what magnitude means? Okay, it means length. So it's some kind of length and it goes in some kind of direction. And it kind of looks like a ray. So if you're really describing it, like if you're to look at, let's say this is our vector. It has, let's make P. This would be our initial point. And then it goes in some kind of direction with some kind of length. And it has, let's do Q, which is the terminal point. And usually has an arrow, sometimes a half of an arrow. So how this would be labeled vector-wise, P, Q, and it has like a half arrow on top. And the arrow always goes towards where the arrow is going, so it goes from P to Q. Okay, have any of you guys taken physics yet? Or can you not take physics?
We're not supposed to.
Okay. So when you go to physics, they like really dive deep into vectors. We're just going surface level. Okay? And I'm not going to make you graph any vectors. So, all right, we'll talk about what does it look like when you combine two vectors, but I'm not going to talk about what the graph looks like. I don't want to confuse anyone. If you go to college and you take linear algebra, you can learn more about vectors. And then the other thing is, when you see vectors, they're usually lowercase, bold letters. So when you're looking in your book, you'll see them as lowercase bold letters, and they usually use U, V, and W. Why? I don't know. Okay, component form of a vector. Looks like this. Okay, it's not parentheses. It's like the arrow brackets, I guess. Okay, that would be like what component form. How you find component form, let's say for these points, like P, which is P1, P2, and Q, which would be Q1, Q2. To find the vector, you take your, so like if it goes from P to Q, you always do terminal minus initial. So it's always terminal minus initial. If it doesn't tell you which one's which, you assume the first one is the initial and the second one listed as the terminal. If it doesn't tell you. magnitude. Which is also the length. And how you represent that is you have like 2 bars, kind of like absolute value bars around it. Okay, and it's essentially the distance formula. So I'm gonna do like from the start, it'd be like Q1 minus P1 squared plus Q2 minus P2 squared. But if you already have it in vector form, you're just squaring the first part of the vector and the second part of the vector and adding them together. And if the magnitude is 1, then it's a unit vector. Okay. And if the magnitude is 0, then it's the 0 vector. So I just love the first section was like all definitions. It's a joy. Okay, and the test you're gonna have next Thursday, that's your next to last test. So you'll have a test over this half of chapter 6, you'll have a test over most of chapter 10. You have your unit circle quiz, and then possibly another quiz if we should be able to get to it over the end of chapter 10. And then your final exam. But I'm not gonna talk about finals till at least till the beginning of May probably. Alright, last definition formula for today. Unit vector. Okay, unit vector is like the smallest vector representing the stuff. So how you find the unit vector is you take your vector divided by its magnitude. Okay, so we're gonna do some examples now. So the first part, finding component form, and then we're gonna find the magnitude. Okay, if it's not labeled, which one's initial, which one's terminal, the first one's always labeled, or first one listed would be initial, the second one listed would be terminal. So if I wanna find component form, I make my vector, then I do terminal minus initial. So this would be -1 minus 4. And my other one would be 5 minus -7, which turns into +7. So what would my vector be? -512. Okay, so that's the first part, that's component form. Okay, then the magnitude. We already solved it to the vector, so to find your magnitude, you do the square root of each part squared. So this would be -5 squared plus 12 squared. So it's negative 5 squared. 25. And whole squared is 144. So this is the square root of 169. Okay, this comes out perfectly to be 13. If it doesn't come out perfectly, then that's when you're going to do your factor trees. Okay, is that one all right? Okay.
Why does magnitude look like that?
Look like what? The 2 bars?
Yeah.
I don't know why. It's just the way it's represented. What would you do if you were to create it?
That's all I was gonna say.
Okay. But M stands for slope.
I would make it a cool M though.
Yeah, it'd be like, you know how you make some of your letters fancy
Maybe like
in math? In
I
math.
make my letters fancy.
Not just
Greek-
you,
Greek
no, like
letters.
math people make like.
She's talking about Greek
Oh, you're
letters.
talking about.
Oh my gosh.
Or you do like Roman numerals, you know, like.
Yeah.
Yeah.
That was on camera though.
That was.
Alright,
I knew it.
so what would the component of this one be? How would I find the first point, first part?
9 minus negative.
Okay, so terminal minus initial, so 9 minus negative 3, which would be 12. Okay, what about the second part? 11 minus 40 or 40 minus 11?
40 minus 11.
Good. 29. If you do it backwards, you're always going to have your negatives flip-flopped. So always remember it's terminal minus initial. Okay, and then to find your magnitude, your square root of each one of these squared, which would be 144 plus some really big number, 841, which is 9, square root of 985. Okay, so then I see, can I break down 985? Okay, you take 5. How many times is 5 go into that?
197.
Okay, pretty sure 197 is prime.
Looks like it.
Since there's not 2 5s, you'd be done.
I feel like Lucas is my translator. He's talking about Greek letters.
He said it really nicely though.
Yeah, I did.
Like he was trying.
I didn't feel that bad about what I said.
Why are you the only one sitting in the class?
I don't know, Nate left me.
Because it's all about him.
Hey, Lucas, your nose is turning brown.
Oh yeah.
You kind of sat there and thought about it.
Alright, how do we feel about component form and magnitude?
When you want to
What?
sit,
Okay.
when you want to sit in the inner circle so bad that you'd sit there alone. That's when you know that you're not on the right path in
The
life.
loneliest point in life is when you're the only one in the inner circle.
Where's Seth?
He's on some boat field trip.
Oh, Hosa.
Lame. Hosa.
That's Hosa, yeah.
It's Hosa. I know what I'm talking about.
What'd you say?
What'd you just say? Did you say best face?
That's
In class? Oh. But you said he just feels entitled because he has the best face in class. Like,
That's when Ruthie
Well, that
made a
too.
move.
power couple.
Things that are on video. Sure the kids are gonna love to go back and watch it.
Lucas, you've had like girls hit on you on video in this class, like multiple times.
You're the one that said you had a nice face.
I did
I
not.
said I like Foxy.
That was an accident.
Okay, so on this next part, when you see this stuff on your homework, it's gonna say graph the resultant vector. Okay, the resultant vector is what you get in the end after you perform the operation, but you don't have to graph. That's why this part over here says no graphs. Okay? So resultant vector is what you get when you do the operation. So like the first part says, we're gonna do 2v. Okay, literally 2v means you're gonna take vector v and you're gonna multiply it by 2. Okay, that's called a scalar. Scalar multiplication means you just multiply by a number. So what would my resultant vector be?
-4 and
Good. Now I know sometimes my brackets don't always look like that. So try to make sure they don't look like sevens. If possible. Okay, so part B says we're gonna take W minus V. So this would be 3, 4 minus -2, 5. Okay, when you're adding or subtracting vectors, you match up first part with first part, second part with second part. So this would be 3 minus -2, which would be 5. And then 4 minus 5, -1. So my resultant vector would be 5, -1. And part C says we're going to do V plus 2W okay, so you have to take 2 times W first, then you add your V to it. So my V is going to stay the same. 2W, that would make that 6, 8. So what would my resultant vector be?
413.
413. Okay, you're gonna throw me in and mix it up.
Oh. Sure.
Excuse me. Okay, this I is not an imaginary number. Okay, when you see it in the book, it's actually gonna be bolded. So like, if I see this in the book, this would be a bolded V, that's a bolded I, and this is a bolded J. Okay? What I is the unit vector 1, 0. J is the unit vector 0, 1. This is called linear combination form. So we had component form, which has the brackets. This is linear combination. Okay, just when you solve it, you're going to do like what you think you would do. Or at least what I think makes sense. Okay, so if I'm going to do 2 times V, that would be -4I plus 2J. What did I do?
Multiplied that.
I just took both of those times 2, right?
Yeah.
So if this is 2 times V, all I did was distribute it, just like we did on component form.
So you wouldn't have to like.
Plug it in.
No, because those are vectors. I and J are vectors. You won't put any numbers in for them. Okay? This would be like saying take -2 times this vector I is this vector, add them together, that would be a component form vector. So this is a different way of showing vectors. So if I want to do W minus V, so this would be negative I plus 2j minus negative 2I plus j. Okay, now when I combine those together, just like before, first part, second part. So negative I minus negative 2I would be positive 1I. 2j minus 1j is j. Okay, i's and j's, do you see any brackets around them? No. Okay, it's not component form, it's a different kind of form. Okay, and then C is V, so that's negative 2I plus j plus, okay, so 2W, what would 2W be?
Negative 2I plus 4j.
Okay. Good. So then what would my resultant vector be if I add these two together?
5j. No.
Close.
Negative 4, alright.
Negative 4I plus 5j. Okay. So if you see the i's and j's, those are the vectors 1, 0, 0, 1. They're unit vectors. Right? Treat it kind of like x's and y's. You're not plugging anything into the i's or the j's. All right, we're going to stop there.